Integral formula for some trigonometric functions. There's a lot of integration formula for trig functions, and I cannot enumerate all of them. No course in differential calculus will walk you through all those formula. So I will just show you a few of those integration formula, and this is it, okay? So the integral of tangent of x dx is equal to negative ln of the absolute value of cosine of x. The integral of secant of x dx is equal to ln of the absolute value of secant of x plus tangent of x plus c, so on and so forth. Okay, so you may be wondering, why is it necessary to put this in absolute value sign? Well, I wish to remind you that your ln function, okay, so if you are getting the ln of a function, that function must be greater than 0, okay? If your function here is 0 or negative, your ln function will be undefined. So that is the reason why it is necessary to put that absolute value sign. So this is the challenge. How do you show that this formula is indeed true? So this is like a theorem, okay? This is like a theorem which tells you that the antiderivative of tangent of x is equal to negative ln of the absolute value of cosine of x. You prove that by going back to the fundamental theorem of calculus. This integration formula is true if and only if the derivative of this function is equal to tangent of x. Okay? Okay, so let us show it. Let us show that the derivative of ln of the absolute value of cosine of x, or the negative of ln of the absolute value of cosine of x, is equal to tangent of x. Okay, so let us show it. So the derivative is equal to, okay, 1 over cosine of x times the derivative of cosine of x, which is negative sine of x. Okay? And so negative times negative is positive. Sine over cosine is tangent. And so there you have it. How about this? Okay, so how do you show that this formula is indeed true? Let us verify the formula using your fundamental theorem of calculus. Let us get the derivative of ln of this. Okay? The derivative of ln of that function is equal to, okay, this is how you get the derivative of ln functions, 1 over secant of x plus tangent of x, and then you will get the derivative of this function. The derivative of this is secant x tangent x, and the derivative of tangent of x is the square of secant of x. Let us factor out secant, okay? And so these are common factors. You are left with secant of x. So that's it, okay? So that is how you verify a formula. You just apply your fundamental theorem of calculus. How about this one? Verify that the integral of cotangent of x dx is equal to that. Well, let us get the derivative of negative ln of cosecant, or ln of the absolute value of cosecant of x. So that's equal to 1 over cosecant of x times the derivative of this is this. Okay? Cancel common factors and law of sines. Now it is also equal to ln of the absolute value of sine of x. So let us verify that. The derivative of this function is 1 over sine of x. And then the derivative of sine of x is this one. Okay? And so that is equal to cotangent of x. So I will leave it to you to verify this formula. Okay, so this is going to be an addition to the list of integration formula that you already know. Okay, integration formula for trigonometric functions. Okay, so let us solve some problem. Let us get the integral of functions such as this, tangent or cotangent of x raised to some exponent. Okay, so these are the things to remember. Your Pythagorean identity. What else? The derivative of your tangent is equal to the square of secant of x. And this one, the integral of tangent of x dx is equal to negative ln of the absolute value of cosine of x plus c. And what else? This one. The integral of the square of secant of x dx is equal to tangent of x. You know what? When I was a student, when I was kind of not really sure about the formula, am I recalling them correctly? Okay, do I remember them correctly? What I do is I verify this formula using your fundamental theorem of calculus. If you want to check if this integration formula is indeed true, all you have to do is get the derivative of tangent of x with respect to x. And it should give you the square of secant of x. Find the integral of the cube of tangent of x dx. Let us begin by factoring out tangent of x. And I did that so that I can use my Pythagorean identity for the square of tangent of x. The square of tangent of x is equal to this. The square of secant of x minus 1. And then I will distribute, and then we shall get the integral term by term. Okay, let us solve this one. So this one should be easy. You can do this using the technique of substitution. Let u be equal to tangent of x, du is the square of secant of x dx. Okay? You can write this as the integral of u du. Okay, so this is your u, and then your du here is this one. That is your du. And applying power rule, this is equal to 1/2 times u squared plus c. And so the integral of this is equal to 1/2 times the square of tangent of x plus c. So this is the first part. Okay, let us now get the antiderivative of tangent of x. And we know this to be equal to negative ln of the absolute value of cosine of x plus c. Let us combine the results of a and b. This is equal to this. Okay, so let us do one more problem. How about this? Find the antiderivative of cotangent of x raised to 4 dx. I know that I make it appear that it is easy to decide on how to start a solution to finding the integral of a function. Okay, I know that is how it seems, but the fact of the matter is, it takes time. It takes time to decide on what technique of integration to use. And sometimes you have to do it by trial and error. Okay, so if you decide to do it using one technique and it leads you nowhere, okay, you cannot find the direction for your solution. You have to scrap it and begin a new solution using a different technique. Okay, so in this case, I will write this function in this way. And then I will use your Pythagorean identity for the square of cotangent of x. The square of cotangent of x is equal to the square of cosecant of x minus 1. And then I will do the multiplication. Okay, now I hope that you can recognize that you can already work this out using the technique of substitution. Okay, let u be equal to cotangent of x. And du is equal to negative the square of cosecant of x dx. So that means this is equal to negative du, okay? So Again, using your technique of substitution, this becomes negative of the integral of u squared. Okay, so this is cotangent du. And that is equal to negative 1/3 times u cubed plus c. Okay, we now go to the second part. How about this? Again, it takes time. It takes time really to decide on what technique to use. And so what I chose here is to use your Pythagorean identity. We already know what is the antiderivative of the square of cosecant of x. And so we shall make this substitution. The antiderivative of the square of cosecant of x is negative cotangent of x, and this one is equal to negative x plus c. So we combine a and b, and this is the result. Okay?